Hi, in this video we will do more examples for the derivatives of logarithmic functions. Let us start by recalling the differentiation rules for logarithmic functions. So derivative of ln x is 1 over x. And then the derivative of log x general base b is almost 1 over x, but there will be a multiple ln of b in the denominator. How about the derivative of ln of a function u? This is chain rule plus the rule above. It will give us u prime over u. And the same story goes for log of u base general b, u prime ln of b u. So these are the rules that you have to know, and we'll use it in different situations. We will need to differentiate functions. Here, let's start working on these ones. Derivative of ln of a function. The rule says we have to find derivative of that function over the function itself. Now the derivative in the numerator, we have to compute that. This is 3x squared. Derivative of x cubed is 3x squared plus 2 minus derivative of e to the power u is u prime. In this case it is 3 e to the power 3x over x cubed plus 2x minus e to the power 3x. Derivative of, again, e to the power something here is derivative of that something e to the power the same function. Okay, so now we have derivative of 2 log x base 2. So the constant multiple rule 2, I can put it outside. Derivative of log x is 1 over x ln of b. Ln of b here is ln 2. And then minus 0 e to the power 2 log of x base 2 minus 2. And that gives us what we have, 2 ln 2x e to the power 2 log x minus 2. The third one, we have a function to the power 3. So the derivative is going to be 3 times derivative of that function times the function to the power 1 less. And that is 3. Derivative of ln x plus 1 is u prime over u plus derivative of 3, well, which is 0. I will write it there. So this is x plus 1 plus 3 to the power 2, which gives us what here? Derivative of x plus 1 is 1. Derivative of 3 is 0. So we get just 3 over x plus 1 ln of x plus 1 plus 3 to the power 2. How about this guy here? Log of x squared minus x base 3. Well, derivative of log of some function would be the derivative of that function over the function itself But since the base is general, not the exponential, the e, the Euler's number, we have to multiply the denominator by ln of that number. Okay, so this is 2x minus 1 ln 3x squared minus x. How about this one? This is nice, f prime of x. You see, there is a ln inside. That is a function. That's something there. So derivative of ln of a box is box prime over box. Yes. So in this case, box is ln x. And we have to find its derivative. What is derivative of ln x itself? Well, in the numerator, we have to find the derivative of this guy, box inside. So derivative of ln x is 1 over x. And, well, in the denominator, we had this ln x. Now you multiply this and that. You get 1 over x ln x. This is a good one. How about derivative of this guy? Well, let me first write what is the best way to see the derivative of square root of a function. So it is log, the function itself is log of x base 2 to the power half. Now you want to do the differentiation, and you need to apply the general power rule. So it will be n derivative of log x base 2 times log x base 2 to the power 1 less. This gives us half of log of x base 2. The derivative is not just 1 over x. It is 1 over ln 2 times x. And this is log of x base 2 to the power negative half. If you simplify, if you write everything nicely, this will be ln 2x 2 root log of x base 2. Okay, let's move on to another example. Find an equation for the tangent line of this graph. Remember, when you have this x is supposed to be 9. Yes, this x is 9, not 0. Oh, 3, sorry, 3, yes. This x is 3, okay. Find the tangent line. So we need a point. The point will be 3, and then plug in 3 into your function. So this is 3 squared log of 3 base 3. This is 3, and log 3 base 3 is 1 times this is 9. That's perfect. Now we need to find the derivative of the function at that point for the slope. So this is derivative of first one times second one plus the first one itself times the derivative of the second one. And this gives us what? This gives us 2x log of x base 3 plus x squared 1 over x ln of 3 in the denominator. So then at x equal to 3, what we have is y prime is 2 times 3 log of 3 base 3 plus 3 squared over ln of 3 times 3. Well, simplify all these things. This is 1. This cancels with that. That is 6 plus 3 over ln 3. It's a strange number, but it is the slope. Our slope here is this, and then y minus y1 equals to m times x minus x1 is the equation. Y minus 9 equals to 6 plus 3 ln 3, this is m, times y minus y1. You can multiply, not y, x minus x1. X minus 3. So that you can simplify. I'm just going to leave it like it is. Okay. For this one, find the values of x at which the tangent line to the graph of this function is horizontal. Remember, horizontal tangent line means that the slope of the tangent line is 0. That means that f a prime at that point is 0. So we have to find f prime and let it equal to 0. Let it set it equal to be 0 and then solve for x. So f prime here is, this is ln of a function. So the derivative of that will be the derivative of the function over the function itself, which gives us 2x minus 2 over x squared minus 2x plus 6. And we set this equal to be equal to 0. This is a fraction. A quotient is 0 if and only if the numerator is 0. So 2x minus 2 is 0. That means that 2x is equal to 2, and that means that x equal to 1. So at x equal to 1, this function has a horizontal tangent line. One more thing. We have a few more things here. Find the acceleration of an object, moving object with the position function this at time t. Okay, so remember the acceleration at time 2 equal to 2 is going to be equal to acceleration at time 2 equal to 2 is the second derivative of function at t equal to 2. So we have to find first derivative of this, ln of this guy. This is t squared minus 1 prime over t squared minus 1 itself. This is 2t over t squared minus 1. That's the first derivative. Now the second derivative is always the derivative of first one. This is quotient, so we have to apply the quotient rule. Derivative of first one times the denominator minus numerator itself times the derivative of the denominator. And then denominator to the power 2. This gives 2 times t squared minus 1 minus 2t times 2t, which is 4t squared over t squared minus 1 squared. You can definitely simplify this, can't we? So this is negative 4t squared. There's a 2t squared there, so this is negative 2t squared. And there is minus 2 also there. And now we are looking for acceleration at time t equal to 2. So f double prime at 2 is minus 2 times 2 squared minus 2 over 2 squared minus 1 to the power 2. This is 8 negative 10, 3 squared 9. That is the acceleration of the object at that point. Very nice. Find dy dx if the x and y have this relation. We have to do implicit differentiation to find the derivative of the function. For this, you always start with differentiating both sides. And then this gives us what? The derivative of the numerator over, the derivative of the function inside ln over the function itself, and then derivative of x is 1 with respect to x. Very nice. And this guy here, derivative of x is 1. Derivative of y with respect to x, we just write dy dx equals x plus y equals to 1. Now we have an equation for dy dx. We solve 1 plus dy dx is equal to 1 times x plus y. And as a result of that, dy dx is x plus y minus 1. That is dy dx for that y and x with that equation. The last example is a related rate equation. So we have this equation, x and y are functions of t. We are trying to find a derivative of y with respect to t at a given point. Oh, one thing is missing here, and that is that the derivative of x at that point is also equal to 2. So dy, find the derivative of both sides of the equation with respect to t. So derivative of x squared with respect to t is 2 dx dt x to the power 1 less, which is 1, plus derivative of derivative of log y base 2 with respect to t. It will be the derivative of y over y itself times ln of 2. This is equal to 0. I guess now we have the equation we are looking for, and now plug in the values. X is equal to 1, y is equal to 4, and what is it? Dx dt is equal to 2. So plug in everything. 2 times 1 plus dy dt over ln 2 times 4. This is equal to 0. Now we have this equation, we have to solve it. So dy dt is going over 4 ln 2 is equal to negative 4, and then you multiply to the other side. Negative 4 times 4 ln 2, which is negative 16 ln 2. And that is the definition we had there. Everything is, well, based on these 4 rules that we recall at the beginning. You have to know them, and you have to use them whenever you need to differentiate a logarithmic function.